You know how your smart thermostat just knows the perfect temperature? Or how a modern camera can somehow cancel out your shaky hands for a perfect shot? Well, the secret behind a lot of that is a concept called fuzzy logic. It's all about teaching computers to think beyond a simple yes or no and start to understand all the maybes and sort ofs that make up our messy human world. Right, so let's just dive in with a really basic problem. If you tell a friend, hey, it's kind of hot in here, they know exactly what you mean. But a traditional computer, it just can't handle that. See, it's built for a world of absolute black and white facts. But we live in a world that's, well, it's full of nuance. And this really gets to the heart of the problem. On one side, you've got classical logic. Everything is either true or false, 1 or 0, on or off. But on the other side, there's us, human perception. We see the world in degrees. Something can be sort of true. It's really the difference between a clunky light switch and a smooth dimmer switch. So the big question is, how do you bridge that gap? How do we get a machine to think less like that light switch and more like that intuitive dimmer switch? Well, it turns out the answer is to embrace all those gray areas, not try to get rid of them. So this amazing breakthrough happens back in 1965. A mathematician named Lofty-Zadeh comes along with this totally revolutionary idea. He says, what if, instead of forcing everything to be absolutely true or absolutely false, we could allow for degrees of truth? And that one simple but honestly profound shift in thinking, that's the heart of fuzzy logic. The way he did this is with something called fuzzy set theory. You know, in normal math, something is either in a set or it's out. There's no middle ground. But with fuzzy sets, something can have partial membership. It can belong just a little bit or maybe a whole lot. It's just a much more natural way to categorize things in the real world. Okay, let's use a classic example to make this super clear. The idea of being tall. If you're using classical logic, you're forced to draw this completely arbitrary line in the sand. You have to decide on one exact height where a person suddenly, almost magically, becomes tall. So let's say we set that line at exactly 1.80 meters. Now look what happens. A person who's 1.79 meters tall has 0 membership in our tall set. According to the computer, they are 0% tall. But then someone just 1 centimeter taller, at 1.80 meters, is suddenly 100% tall. That just feels ridiculous, right? But now, check out how fuzzy logic handles this. It solves the problem by assigning degrees of tallness. So a person at 1.7 meters might be, say, 20% tall. At 1.80, they're 60% tall. And at 1.90, they're 90% tall. It creates this beautiful, smooth, gradual transition that just feels so much more like how we actually think about the world. So this whole process of mapping a real-world value, like someone's height, to a degree of belonging between 0 and 1, is all handled by something called a membership function. You can think of it like a rulebook or a translator that defines what kinda tall or very warm actually means to the computer. It's how we turn our fuzzy human intuition into a language the machine can finally process. Okay, so that's the theory. But how does a machine, like your smart air conditioner or your car's anti-lock brakes, actually use this to make smart decisions? Well, the whole process is run by what's called a Fuzzy Inference System, or a fuzzy logic engine. This system basically mimics human reasoning in 4 key steps. First up, fuzzification. This is where it takes a precise input, like 22 degrees Celsius, and makes it fuzzy by describing it in human terms, like 70% warm. Next, it looks at its rule base, which is just a set of simple if-then rules that an expert programmed in. Third, the inference step cleverly combines all the relevant rules to come up with a fuzzy conclusion. And finally, defuzzification. That's where it translates that fuzzy, nuanced conclusion back into one single, crisp command the machine can actually follow. And really, the heart and soul of the whole thing is this rule base. It's where you store expert knowledge, but in this incredibly simple, readable format. You don't need complex equations. All you need are these intuitive rules that just feel like common sense. If the temperature is cold, then the heater output should be high. It's a surprisingly powerful way to capture human expertise. And in that last step, defuzzification, the system has to translate its fuzzy conclusion, which might be a mix of ideas like increase the heat a little and turn the fan on slightly, into one single precise command. A really common way it does this is the centroid method. Think of it like finding the perfect balancing point. or the center of gravity of all those different fuzzy suggestions to come up with one crisp final decision. Now here's the coolest part. This isn't just some abstract theory. This four-step engine is quietly working away in devices you probably use every single day, making them smarter, more efficient, and way more responsive to what's going on around them. Honestly, you would be amazed where this stuff is hiding. In modern washing machines, it's sensing how dirty a load is to save water. In your car, anti-lock brakes use it to react to a slightly icy road. That camera in your phone, it's using fuzzy logic for image stabilization, compensating for a somewhat shaky hand. It's the secret sauce that lets these devices adapt so intelligently to our messy, unpredictable world. But this whole idea is so much more than just a clever programming trick. At its core, it really represents a completely different way of thinking about information and, well, about uncertainty itself.
Now, there's one thing that people always get mixed up, so let's clear this up right now. Fuzzy logic is not the same thing as probability. Probability deals with the chance of something happening, like an 80% chance of rain. But fuzzy logic, it deals with the ambiguity of meaning, like saying a person is 80% tall. One is about randomness, the other is all about vagueness.
And what this all leads to, really, is a pretty big philosophical shift. Fuzzy logic challenges this old idea that knowledge has to be perfectly precise to be useful. It teaches us that vagueness isn't some flaw we need to eliminate. It's a fundamental feature of our reality, one we can actually work with. So that leaves us with this really fascinating question as we look at the future of AI. If real intelligence isn't about absolute certainty, but about how you navigate a world of nuance, what happens as our machines get better and better at it? By teaching computers to think in shades of gray, we might just be taking one of the most critical steps toward creating truly intelligent systems.